Our next presenter is Arjan Koopen, who was responsible for the infrastructure at a recent camping event that many of us attended. And I asked him to give us a little bit of insight into how you create decent internet infrastructure on a camping site. So the talk is fiber to the field, tent and boat, and this is literally what happened. Arjan, the floor is yours.
I'm going to talk a little bit about the network infrastructure we've built for SHA2017. Thank you. So SHA2017 was held just a couple of weeks ago, and it's a 5-day non-for-profit outdoor hacker camp, conference and festival for around 3,600 hackers. And this time it was held at Scouting Landgoed in Zeewolde. And it's a fairly large terrain. It's a 1 by 1 kilometer terrain, and it's right next to the NLNOG, and it's in the Flevopolder. SHA had around 200 presentations in the course of 5 days on all sorts of topics like internet freedom, privacy, security, hacking, and that kind of stuff. And it's the successor of a long line of Dutch hacker camps that have been held for every 4 years since 1989. And the last couple of them are What the Hack, Hacking at Random, and Observe, Hack, Make. Similar events like these are the Chaos Communication Congress and Camp held in Germany, and Electromagnetic Field in the UK. And if you'd like, you can actually visit a hacker camp like this every year. You either have to go to Germany or UK or Netherlands, and these camps, they swap around basically every year. For the SHA2017 network infrastructure, we build a network which is operated by Team NOC, or the Network Operations Center, and it's a team of around 30 volunteers. It's a reasonably international team with members from all across Europe. And there's also quite a bit of overlap with the other events like CCC and EMF. We basically run our own small-scale ISP with a temporary ASN and some temporary IP space. The network is used for public internet connectivity, either wired or wirelessly. We do video streaming and relaying for all of the talks that are held on the conference. There's VoIP. We have a local data center facility or co-location for all the teams that need to have some equipment housed or co-located. We do stuff with lights, with ArtNet, and ticket scanning over Wi-Fi is also important. But how do we deliver this network? So we have this map here, and which on this URL it's still online, I think. So we did a lot of the planning of the on-site network infrastructure on a map. And you can go to this URL, enable the NOC layer, and then you can see all of the physical network infrastructure we've built. On this site, there were already 3 utility buildings from Scouting. And we use these utility buildings as small data centers. Scouting also invested quite a bit in this terrain and installed quite a lot of single-mode fiber infrastructure. And there's 11 distribution boxes spread across this field. From these fiber distribution boxes, we use fiber to go out to our points of presence. And those points of presence are on this map. I don't think you can see it that well on this projector, but it's basically the gray circles that are spread across the campsite. And a point of presence is serving around a radius of 40 meters on the field, so you can get a bit of a sense of scale here. To uplink all of these points of presence, we use about 50 fiber cables, mostly single-mode fiber with multiple cores in them. On this map, you can also see that there's well, you cannot really see it in this one, but we are here next to the Nulder now, and there's a pier also where boats could dock, and so you could visit the festival by boat, and then you could also get network on the pier because we also deployed a point of presence over there. And this is our point of presence, or a datenklo. And it's something the Germans invented because data klo is data toilet. On the outside, you can see there's a Wi-Fi access point, and that's mounted on a wooden pole, and that we put that in the chimney of the toilet. There's also a ArtNet node on the outside, which displays an animation of LEDs, and that's network controlled. So that gives us a sort of network monitoring as well, and also for the visitors. So if there's no animation playing on these LEDs, then they know that the network is not working in that datenklo. On the inside, there's a switch, and this time we used a lot of Arista switches, and those switches offer 1 gig copper ports for the end users, and also a couple of 10 gig ports, so the switch is uplinked with 10 gig, and there also were a couple of villages that wanted to get also a 10 gig connection from datenklo, and so we happily provided that. In here we use a lot of single fiber 10 gig SFP, so we save up on fiber cores. And you can also see on the bottom there's these large spools of fiber, and those are multi-core single mode fibers, and we mostly terminate themselves, so we splice patch leads on those fibers. So, then the data centers, there were 3 of them spread across the site. In the utility buildings from scouting, there was already a telco rack with all of the fibers terminating that were going onto these distribution boxes. We did have to install some air conditioning to keep all of our equipment cool, around 30 kilowatts of cooling capacity we had. Well, we had a number of flight cases we put in there with servers, with networking stuff, just for our own NOC team. Then we also had sysadmin, the POC, which is the Phone Operations Center, and they provide a local phone service to all of the visitors, so you can bring your DECT phone and you can call everybody on site. And you mostly use the copper infrastructure, which is also on site. And then we have the VOC, or Video Operations Center, that do a video streaming and relaying. For the uplink to the site, we used a 59-kilometer dark fiber that was provided by UNET. For us, this was the easiest uplink ever, since this fiber was already installed on the site. And at previous events, we needed to pull kilometers of fiber to a field, and this time we just didn't have to do that, so that was very easy. We decided to go, we wanted to have a 100 gigabit uplink to the site, since we had the dark fiber. We ended up using, or loaning routers from Juniper, MX240s, and we deployed, since we were having this long dark fiber, we used a coherent 100 gigabit solution, and for the people interested, here are the part numbers from Juniper. After we deployed the 100 gigabit connection, we discovered that we only had around 13.5 decibels of loss over 1550 nanometers. And this meant we actually had quite a bit of link budget left over, so we decided to also install passive muxes, so we can get a 10 gigabit backup uplink. So we had 100 plus 10 gig. In the end, we only did about 11 gigabit over the connection, so we at least went over 10 gig, so it's justified, I guess. So for our uplink to the default free zone, we got a temporary ASN and some IP space from SurfNet, so that's why the very low ASN number. And the IPv4 space from SurfNet was important because we have to have some space for bootstrapping, because the other space we get is a temp assignment, and that temp assignment is only for 30 days, and that's not really enough for our preparation phase. So it's good to have a little bit other IP space we have more early on, so we already know what the addresses are and we can start configuring stuff. Our upstreams were NTT, Core Backbone, SurfNet, and NLEX, and NTT happily provided another 10 gigabit besides the 100 gig of transit they did, and we used that 10 gigabit for our backup uplink. So we had an MX240 in NICHAF and one on the site, and if for some reason the MX240 in NICHAF would fail, then we still have a BGP session on the MX240 we have on the campsite directly to the backup entity uplink. And we ended up not having to, we didn't use that, or the 100 gigabit connection didn't go down, so we didn't use it in the end. We'd like to collect a number of statistics from our network. One of them are how many devices have connected to our network. We do a little bit of sort of DHCP fingerprinting, and based off that we can count the number of devices that have connected to the network, and we also know what kind of devices they are. And almost 90% of the devices were on Wi-Fi, so there's not that many people using the wired network. There are 2,000 of these devices are actually the conference badges, and these are these PCBs that were handed out to every visitor of the conference. And I think they produced around 4,500 of them. And yeah, 2,000 of them connected to the network, and it's an Espressif chip in there. It's 2.4 gigahertz only, but yeah, it worked. Another thing that has been deployed was what we call the Pixelflut. And the Pixelflut is a LED wall, of an LED wall that was deployed at the bar. And this LED wall has all of these pixels, RGB pixels, and you could control them over the network. You just send a packet for a certain coordinate with your color, and then you can just start coloring all the pixels on the screen. And this, was getting quite a bit of traffic, so luckily we also had fiber to the bar, and we hooked this machine up with a 10 gigabit connection, and in the end it peaked up around 4 gigabit-ish of traffic. So that was, and I think there were some people just spawning VPSs from external, and I heard something about somebody having 42 VPSs just trying to get something on the screen. But, yeah. Right. Well, while building network, we also learned a few things. Well, one of the things is that we deployed quite a heavily routed network this time. And the reason we did this is that we are dependent on donations from various sources, and we have had donations for networking hardware from Booking and from Cumulus. But most of these switches are data center switches. And because these switches are data center switches, they are not good at routing for lots of clients, but if we distribute the load quite a bit, it works out all right. So we used the principle of route early and route often, so we did routing at every datenklo. And this was previous from different events where we mostly put like 1 or 2 or 3 big boxes, and they route basically all the subnets, and we have just switches sitting inside the network that were doing only switching, doing only layer 2. Well, we gave every datenklo a /24 IPv4 subnet and some /64 for v6. We ran OSPF v2 and v3, and yeah, only for Wi-Fi we had some layer 2 stretching requirements, because if you're roaming across the site, you don't want to hop between subnets. So, but we were able to solve it because we were running Aruba solution with a controller that could tunnel all the traffic over this IP network to a central point and then break it out at that point. So that kind of solved that issue. Yeah, well, this concept for us worked pretty well. Then also, we had Cumulus as a sponsor this time, which meant we were also using white label switches for the first time. So for those guys who are not familiar with the concept of Cumulus, Cumulus is basically a install of Debian with a switch daemon. And the switch daemon does synchronization of information in the Linux kernel, being routing information, bridging, and IP tables, and some other information. And that syncs that to the Broadcom hardware. These switches worked well for us as either distribution routers. So we had the Arista switches in the data enclose doing local routing, and then that connects to the Cumulus distribution router. So we didn't have much clients talking directly to the, on layer 2 to the Cumulus routers. And we use them as a few of them as data center switches. We also tried out in another part of the network in what we call the Orga network, multi-chassis link aggregation with VRR. And VRR is a sort of active VRRP that kind of load balances layer 3 traffic over multiple routers. And to our surprise, this worked fairly solid because MC lag sometimes can blow up in your face. At least some people might have that experience, but for us, it worked well. We did have a few problems. One of them was that we were at first using Quagga as our routing daemon on Cumulus, and Quagga was crashing quite often, and we discovered this was due to the OSPF v3 implementation. We ended up replacing Quagga with Bird, and everything worked fine. Another problem we had was we used Tomahawk switches for doing the central Wi-Fi routing, and these Broadcom Tomahawk switches are 32 times 100 gig with a Intel Atom x86 CPU in there, so it's fairly powerful box. But it wasn't powerful enough for routing a /19 of IPv4 space. I think we had around like 4,000 to 5,000 clients in that one subnet, and we were seeing the load under control plane going up at least too high, and this was mostly due to a large number of ARP packets either coming in from the outside, from port scans, or just clients sitting in that subnet. Yeah, this resulted into Bird was dropping its OSPF v3 adjacencies since the load was basically that high on the box, and at that point we didn't have any v6 anymore on the Wi-Fi network. So after this, we decided to move this whole subnet to the Juniper MX240 we had on site, and that pretty much solved that issue for us. So. Yeah, so what we've learned of this, that if we're deploying Cumulus, then we don't want to have a lot of clients talking directly on layer 2 to the Cumulus box if it's doing any routing. We also did a few things with automation, since we have not that much time for build-up and preparation, so automation is important for us, and a few things we did was config generation for the switches switches and routers we use. So for Cumulus, Arista, Juniper, and HP, we had some scripts generating all the config, and this is also important when you're doing this route early setup. So that config gets a little bit more complicated than just a normal layer 2 switch. We did a little bit of integration with the Netbox IPAM solution we were doing, so we were documenting all the subnets for our network in the Netbox and pulling that information out for generating configs. We also had our topology in, we documented this in a web-based drawing tool named draw.io. We added all sorts of attributes to all the links, and we were able to generate a topology from this diagram and use that to generate configs. We didn't have too much time for getting Ansible all up and running for the Cumulus switches, but we at least did a few things during the event when we had to push changes to our Cumulus distribution switches, and we used Ansible for that. Lastly, well, we're for a number of years we already use Git quite heavily, and recently switched to GOGS for as a sort of GUI around this, and we use also the issue tracking feature within GOGS to have a list of all the open tasks that need to be done. So this was my presentation. We have a few, well, most of our documentation and scripts we've been working on, we've put on GitHub, so it's on the SHA2017 GitHub account. We also have a number of sponsors, which are here on the slide, and most of the hardware we use for this event is in Stichting Event Infra. So if you have any spare hardware or old hardware lying around you want to donate, then please look at our this URL.
Thank you. That was a good, concise talk. We have time for one question.
Yeah.
Not a speech, question.
Okay, so Philip Homber, random hacker. So I start with the speech part. So at Hacker Camp, you have the existential question, do I want to have wired Ethernet in my tent or not? Mm-hmm. And so 2 years ago at the CCC camp, I installed it and then didn't use it. So this time I did it the other way around. Opened my laptop, lo and behold, there is working Wi-Fi at my tent. Well, all set. Mm-hmm. Turns out my laptop was the only one that had working Wi-Fi. Our phone didn't work, and then we got the nice goodie, the badge, and that certainly didn't have Wi-Fi. Mm-hmm. So now my question is, what is the future of Wi-Fi? Is now the next thing I bring to a camp, like my own personal Wi-Fi base stations, mm-hmm. so that hook it up to the wired Ethernet and be in business? Mm-hmm. Or do you guys have way better monitoring such that you can install micro base stations at our village when it doesn't work?
Mm. Yeah, so there were like a few spots where we had some issues with Wi-Fi coverage, and anytime when somebody complained to us, then we were able to help them out to deploy basically an access point in their village, and so that would be maybe for the next year. So if you have any problems that we don't know about, please report them, and then we can hopefully fix it.
Typical losers, we complain to each other and not to the NOC.
Yeah.
All right.
Okay.
Thank you. A big applause for Arjan.